All right. So chapter 1 covers just, I guess, you would think it would cover what is business statistics, but it kind of does. But it also it's about what is like data and data sets and all of these things that we're working with in statistics. So the reason we have a separate statistics course for business than we do from like general statistics, and they have a separate statistics course for social sciences, although they don't here at EAC because there's not enough volume, I guess. So is that even though it's the same math, our uses are not different. They're kind of customized to what we need. So you think about, let's see, at one time you talked about maybe even going into accounting, right? Are you still considering that as a career field? Anybody here interested in marketing, going down that road? No? What are you interested in? It's not accounting or marketing. What else is there? Management? Finance? No, that's too much math, right? All right. So think about the sort of information you would want to know to help you run your business better. Okay. So I'll give you some like examples from my own business that probably seem maybe obvious, but I wanted to know of my customers, which ones pay with cash, which ones pay with credit card, and which ones pay with check, which is almost none anymore. Then I wanted to know, is there a difference between cash payers and credit card payers when it comes to on-time payment? Like, are cash payers more likely to be late, or is it about the same? And I found that credit card payers typically are more on time. My business is a monthly subscription type thing, right? It is a storage business. And so people just have their stuff in there from month to month. And so that data led to us, creating like an auto payment system where all you do is sign up, put your credit or debit card information in there, and then you choose the day of the month, and every month it comes out. Other businesses have that, but I'm a small business and it cost me money to get that set up. So I needed to decide if it was worth it or not. And I found that my defaults and my need to auction people's stuff dropped dramatically when I got more people to go on to auto pay, right? Because a lot of the people that would miss payments weren't missing them because they were horrible people. They just weren't good at managing money. Probably the reason their stuff is in storage, right? Because they have more stuff than they know what to do with, and that's usually not a good use of money. But sometimes there's a legitimate reason, like you moved and you downsized houses, and what are you going to do with your stuff? But there's other people that were like chronic storage users, and then like, I'd be like, what do you have in there? And they'd be like, it's a bunch of trash. Like, you're paying me $70 a month to store trash. So that's life, I guess. So, and no matter what sort of business you're thinking of, maybe you have a family business, think of how data is used or how it could be used to make the business more efficient. Okay. So data or data, that's the guy on Star Trek, The Next Generation. So there's some terminology that will be helpful to sort of learn. So the first thing is variables, and variables are data that change from one person to the next, or from one subject to the next, or from one element, okay? So they use the name element names. So in this case, here we have a table that shows nations, their World Trade Organization status, their per capita gross domestic product, and their Fitch rating, which a Fitch rating has to do with if they were to issue debt, like a bond from their nation, rating, and then down from there. Double B minus is not so great, okay? So we would call this the element names, and these the variables, and then each of these would constitute a data set. Their GDP, their rating, and then one piece is called an observation, which means we looked at that nation's Fitch rating, made one observation, and it was AAA for Austria or Australia for both. Okay. Both good places to park your money. Okay. You just have to have a different accent. All right. So that's just terminology. Okay. Is it not going to work? Let's try this. Maybe that will help. All right. So the next thing we need to understand, and this is stuff I would probably take notes on. Okay, I'm not, you can learn how you want to learn, but these become important for this next chapter, which are scales of measurement. So data come in different types or different scales of measurement. The first is what's called categorical data, and the second are what's called quantitative data. Categorical means data that we use to categorize things. That's why it's called categorical, as opposed to quantitative, which means mathematical data that we can use to compare and even mathematically compare things. You'll notice that under categorical, we have numeric data and non-numeric data. So sometimes there's numeric data that's still categorical. I'll give you an example. Or is mathematically, you can't like add two license plates together and it tells you something. Okay, so that's what we would call nominal numeric data. Nom is a Latin root for like name, like nombre in Spanish, right? So it just means name. Nominal data just provides a name for things. Okay, so even though it's numeric, it's just the name it's just a name of something. Zip codes are that way, right? Thatcher's 85552, Safford's 85546. Those numbers don't mathematically mean anything. They're just the name given a designator for a place. Okay. Sometimes we have ordinal data, and ordinal means we can put it in order, and the order means something. Okay. Like first grade, second grade, third grade, fourth grade. Okay, it's still just a name, but the order actually has some meaning to it. But you can't say like, oh, 2 third graders, 3 + 3 are equivalent to a sixth grader. Like mathematically, that doesn't mean anything. Okay, so we could use categorical data that's numeric in nature and is either just a name, or even order doesn't mean anything, or ordinal, where the order means something, but it still doesn't mean anything mathematically. We can also, under categorical, have non-numeric data, where there's a name or it's ordinal. So an example of non-numeric ordinal data might be like freshman, sophomore, junior, senior, right? The names fit in an order, but other than that, that's all they mean. Whereas if we said, the red team, the blue team, the green team, and the orange team, that'd be purely nominal. They're not in some order. Does that make sense? Okay, so that's categorical data. It's just a way we categorize things. And even when we have numbers, the numbers don't really mean much as numbers. They're just used as labels or titles. Okay. The other type of data is quantitative. And so when we talk about quantitative data, now we're talking about numbers that have meaning. Okay. And so all quantitative data is numeric. There's no non-numeric quantitative data. And it's broken into what's called interval data. So interval between the numbers, but there is no true zero to the numbers. Okay. Whereas ratio data has a true 0 point. So a true 0 point means 0 represents the absence of the thing. Okay, so if I have $0, that means I have no dollars. So dollars would be a quantitative numeric ratio measurement. Okay, but temperature, if I have a temperature of 0, it means what? If I'm in Celsius, it means it's the freezing point of water. If I'm in Fahrenheit, it means it's even colder than the freezing point of water, but it doesn't mean the absence of temperature. Okay, maybe absolute 0 means that. That doesn't even mean the absence of temperature. It just means the temperature at which life as we know it stops or whatever, right? Like, I don't know, I'm not a physicist or anything, but so that's the difference. With interval relationships, there's a meaningful difference, so we can use them mathematically and things like that, but there's no true 0 point. And with ratio information, there is a true 0 point. Okay. And they'll probably, what stinks about these is there'll be like some confusing question on the homework. And you're like, I don't know which one that is, but it does matter as we get into looking at data sets to understand what kind of data am I dealing with here? What does 0 mean in this data set? That can be important. All right. So this is mostly just telling you all the stuff that I just said. So I won't read it to you again, but I will kind of go through it. And maybe read a few things. Sometimes categorical data, you'll still see it or hear it called qualitative. They used to always say qualitative or quantitative. And I think maybe those were so close, they confused people. So somewhere along the line, they changed the name to categorical and quantitative. But that's all that needs. Quantitative data, like I said, these two terms are going to come up a fair amount. Quantitative data can be broken into two other types of group. One is called discrete, which is used for measurements, and the other is called continuous. And the difference is when we use discrete quantitative data that we only use whole numbers, okay, 1, 2, 3, 4, 5, 6, 7. With continuous data, we can also use any decimal in between those. So if you think about it, when we get into probabilities, for example, if we say, okay, we have numbers 1 through 20, what's the probability of choosing, reaching into a hat with balls numbered 1 through 20 and pulling out a 6? And the answer would be 1 out of 20 or 5%. Okay. But with continuous data, so now it could be any number to any decimal place between 1 and 20. So it could be 1, 1.1, 1.01, 1.001. You get the point. And we could do that for 2, for 3, for 4. And then the answer is, so what is the probability of grabbing a number of any particular number out of that? And the answer is it's 1 over infinity, which means essentially 0. Okay. So that's why it matters if I'm using discrete numbers where I'm limited only to whole numbers, or continuous numbers where it could be any crazy decimal number in there, right? All right. And like we said, quantitative data is always numeric, and ordinary arithmetic operations like you've learned since you were in whatever grade, probably kindergarten, apply here. Addition, subtraction, multiplication, division, square roots, stuff like that. All right. So I mentioned these already: nominal, ordinal, interval, ratio, but it bears repeating. Nominal just means it gives a name to something. Ordinal means we can put them in some order, but the number, the relationship between the numbers isn't meaningful. I can't add up 3rd grade and 4th grade and get a 7th grader. Okay. Interval, like I said, no true 0. And then ratio has a true 0. Okay. Oh, they're going to tell us each one. So they have an example there. So an example of ordinal they have on there was like those Fitch ratings, right? It means something. Like an F rating is worse than a AAA rating, but is a D rating twice as good as an F rating? It doesn't mean anything in that sense. Interval, always numeric. So Melissa has an SAT score of 1985, while Kevin has an SAT score of 1880. Melissa scored 105 points more than Kevin. That's an interval relationship. And then finally, ratio. So in addition to having a true 0, also recognize that with ratio, the ratio between the two, like in other words, if I divided them, is meaningful. Okay, it isn't always an interval. And it has a 0 value that indicates nothing exists for that variable. So that's really the difference. And again, this is kind of terminology. We're not getting into how to do the math yet, right? This is this first chapter where they're introducing concepts. So Melissa's college record shows 36 credit hours earned, while Kevin's shows 72 credit hours earned. Kevin has twice as many hours as Melissa does. If somebody had 0 credits, that would mean they hadn't earned any credits, right? It would have a 0 would have a meaning of none. All right, other ways they divide up data versus what's called cross-sectional versus what's called longitudinal. Cross-sectional data are collected at the same point in time. So if we were to say, today's not a good example because nobody has grades yet, but if I was to say, what's everybody's grade in the class right now at this moment? That would be cross-sectional data. And it's called cross-sectional because we're looking across the different subjects and saying, what is their score at this one moment in time? Does that make sense? So when you hear cross-sectional data, it means one moment in time comparing across subjects, as opposed to data usually on the same person or same subject, but over time. What was your grade on the first, the first Monday of class, second Monday, third Monday? And we'd see like a time series. We say, oh, their grade climbed. Oh, and then they hit that exam and everybody went down and then it went back up or whatever. And so those have different uses and they're valuable for different things, right? It's valuable to track how things change over time. It's also valuable sometimes to see how everybody's doing at a given moment in time. So we could be like, oh, this one student is struggling and everybody else is doing fine. We can offer additional help to this student. Okay. But sometimes you see students who started really good and they're sort of doing this over time, right? And again, that would help us want to get an intervention in there to be like, hey, intervention. It sounds like your whole family is going to be in a room. You think you're coming for ice cream, and then it's like, so we noticed your grade's been dropping, like that. All right. I'll have to bring it for you guys. I was thinking of framing it and putting it on my wall. My mom gave me this like folder with like papers she saved from kindergarten all the way through like high school. And somehow in there is my first EAC report card for my first semester here as a student, my only semester here as a student at EAC. And it's all W's. Like I like withdrew from, so your teacher is an EAC dropout. And don't worry, I did go back to college later and learn some stuff. So I'm not just like pulling stuff out of nowhere, but I thought that'd be a fun thing to like share with all my online classes. Like, don't worry, you could start rough and still do okay. That's you can, anyway, I frame it and put it on my wall. I don't know, like what message would it tell me? Would it be like, you could start weak, but with hard work, you could be successful? Or would it be like, don't really worry about crap because it's gonna be fine, like that, whichever. So here's a time series graph, right? You can see this is the average price per gallon of gasoline and then the date. So here they're tracking it all across. Right now it would be here-ish, yeah, about $4. So it would have like gone up and then dropped back down a little bit. Isn't it stupid that right now we're like $3.90? What a great deal. Thank you. Thank you so much. Like we're grateful that it only costs $50 to fill up our car. Like something not right about that. All right, 2 places we get data. Primary data, that means data that we collect ourselves, as opposed to secondary data, which means data that somebody else collects and then we steal it for our purposes, right? Or use it for our purposes. So primary data can be observational. Like maybe I want to see how many people use the Commons Lab. So every, I can just have the person I have working in there put a tick mark down every time a person comes in there. That would be observational primary data. We're collecting it and we're not controlling any variables. We're just seeing who comes. Or it can be experimental, where we say, we're going to try to control some of the variables here, right? We're going to, just give people 2 choices of food at the cafeteria, at the cafe. Is that what you guys call it? Yeah. We're going to give them like Cali Club or the Gila Monster sandwich and see what they take more, right? Or I mean, we could have more variables than that, but we can control the variables, right? Maybe we introduce a new product there and then see how that affects sales. That's experimental in nature. And then the other type is secondary data. So that's like taking data that already exists. I do that here at the college all the time. There's stuff that we have to report to the federal government because we do financial aid and stuff that can be valuable to me for making decisions about running the division, right? So I'll take that same data and be like, oh, what do we learn about students who, have, we can take a list and we can sort and filter it by certain things, and we can be like, oh, students who are first generation students do better when they have some type of a intervention, like tutoring intervention or something, whereas that value of that diminishes as you have a student who's had college graduates in your family for a couple generations, and so my kids are more comfortable with going to college because it's just a norm in our family, whereas someone who never had, like, it's not. And so we track that data and we use that to offer more services to people who need it, right? All right, we're almost done. So here's an example. Hudson Auto would like to have a better understanding of the cost of parts used in the engine tune-ups performed in her shop. She examines 50 customers for customer invoices for tune-ups. The cost of parts rounded to the nearest dollar are listed on the next slide. So first of all, what type of data is this? Is this primary or is this secondary? It's a little confusing because she's pulling it from her own business. So you could argue it's primary, but it wasn't collected for the source of data. It's just customer invoices, okay? So you would say this is data that already existed. It just is internal data. And now she's pulling it for the use of statistical research, okay? As opposed to saying, I'm gonna go out and get data for this research, which would be primary. Does that make sense? All right, so here it is. The problem with that data set is it's just not very meaningful the way it's expressed right there. But it would be that simple. You'd be saying to your office assistant or something, hey, pull the invoices and write down the parts cost for the last 50 tune-ups. And so that's what she did. So one way that we can make the data more useful is to create what's called a frequency table, or sometimes they call it a tabular summary, which is boring, more boring than frequency table, where they create classes, in this case, $50 to $59, up to 100, 109, and then show the frequency of each one, and then they find the percent frequency. How do you think they find the percent frequency? Like, where does this number come from? What would you guess? Yeah, you just take the frequency divided by the total, right? So if you were doing this on Excel, you could just be like, this cell equals this one divided by this one. And then if you lock this cell in place, you can just drag it down and it's all done, right? It's super easy to create a frequency table. All right, so what do we learn from that? Well, I learned that about 58%, 26 and 32 there, are between $60 and $79. More than half are in that range. That's something interesting. But that's much more useful. So just like in accounting, where we're like, part of an accountant's job is to take disparate information and make it so that it's more usable by the people who need to use it, statistics is the same way. How do we take this data and summarize it in a way that's meaningful and useful and can help us make decisions? Okay. Here's a graphical summary of it. We call that a bar chart. You probably learned about those in 6th grade or something. Again, that's nice because it helps make it pretty clear where most of them are. So that's just kind of an example of using basic statistics. We'll learn some much more advanced stuff, but to start with, just taking this and turning it into that makes it way more useful. And then that probably even more useful depending on the person, right? All right, so one last thing to cover here is the difference between descriptive statistics and inferential statistics, okay? I do feel like this first chapter is like just a bunch of info to kind of give you all these terms and stuff, but that's how it is. So descriptive statistics are what the name implies, they describe things, okay? So like an observation. So that last one we looked at, that was descriptive statistics, right? We're gonna look at the cost of parts in our tune-ups and see what that tells us about things, okay? So let me see, anything else worth reading on here? The most common numerical descriptive statistic is the mean or average. That's something you're familiar with. How do you find the average of something, you remember? Yeah, you add them up and then divide by the number of data points, okay? If they were gonna write that in like mathy terms, it would look scary because it would be like an epsilon. I can't do an epsilon, but that's roughly an epsilon, like that. That means the sum, right? And then it would be the sum of n1 to whatever the highest number of n is, divided by n, which is the total data points. Actually, it would be x1. That's one thing we'll have to learn in this class, is like how to demystify those crazy looking formulas, because they use all the Greek letters and statistical formulas, and you're like, ugh. But like once you look at, like, I know what that means. It means the sum, or the total of each of the data points added up, divided by n, which is the number of data points that there are. All right. And so the mean measures something we call central tendency, or toward the middle of, what's the middle of the data set roughly. And we'll also learn about median mode, which you probably learned about in high school or even middle school math, and then forgotten, but it'll be just review. So we could find like Hudson's by adding up the 50 tune-ups, divide up, and we find out that it's $79 is their mean. The other type of statistics, so if we have descriptive statistics, is what's called statistical inference, or inferential statistics. You'll hear it called that, which means where we take data from today and we make guesses or inferences about the future, or we take data from a small set called a sample and we make guesses or inferences about the population. Okay, and that is a little bit more sophisticated math, right? And not so much sophisticated math, but sophisticated in the sense that we need to make sure that those inferences we have a reasonable chance of getting them right, okay, which is the hardest part about it. So terms you'll see there are population, which means everybody. A sample is a subset of the population. So if we're going to say all students at EAC, you could be a sample of all the students at EAC, but we would probably get some error in the sample because you're business majors and you're taking a course that's typically a second or a third semester course. So you may not be representative of everybody here. You see the brand new kids here today. They're like looking at their schedules, like going, see how much you've grown up in a year? You're such good kids, right? And then there's some other terminology up there. Again, I won't read it all to you because you're smart grown-ups. This course emphasizes a use of Microsoft Excel. Okay, so be prepared. How many of you feel like you have okay Excel skills? How many feel like good? Like I'm good at Excel? Nobody? How many are like, I feel clueless in Excel? You're not clueless, but you don't feel good. Okay. So you might want to, this info right here, and again, this slide is in the slide deck if you just want to look at it, but this tells you the functions for these first four statistical measures. It's kind of hard to see, but the first one is the average or mean. In Excel, you just put equals average and highlight the data set, gives you the middle. That's so much easier than being like, I'm going to take the sum of all these, then I'm going to count up how many there are and divide them. You just hit equals average, highlight it, and it gives it to you. The second one is called the median, right? The median is like the center point of the data set, not necessarily the mean. So again, Excel can do that just by hitting equals median, highlighting the data set, hitting enter, and it gives it to you. The mode, anybody know what mode is? Yeah, it's the data, it's the observation that appears the most in the data set. Okay, so you can hit mode.sngl, and then the range. The range means the highest data set, point in the data set minus the smallest, and that's the range of the data set. We're going to learn lots of other things too, but these are the first four basic ones. And like I said, the book is pretty good about giving you these, and then when we need them, I'll also go over them. And I even try to help you do a little bit of a translation from this sort of mathematical notation to Excel notation, because it's a little different at times. Okay, so that's a good intro to the course. We do have a guided assignment for this first chapter. So when we meet together Wednesday, be prepared to do that, which means if you're not already signed up for Cengage, try to be signed up before class starts on Wednesday. If you're like depending on that 14-day trial, you might wait till Wednesday morning so that you get 16 days from today. But if you're using Cengage in your other classes, for those of you that aren't, I'm sorry that you have to pay for Cengage for only one class, but again, you'd have to for my stat lab too. We good? Any questions? All right, have a great day. You guys are so easy.